already know how to multiply and divide numbers written in scientific notation. In today's lesson, I will show you how to raise powers to powers when the numbers are written in scientific notation, and we will combine the new knowledge with multiplying and dividing. So once you've completed today's lesson, you should be able to multiply, divide, and raise powers to powers when the numbers are written in scientific notation. Before we get to the main part of today's lesson, which is raising powers to powers, let's review the rules of exponents that make today's lesson possible. The first rule, to multiply powers having the same base, you keep the base and add the exponents. So x to the a times x to the b is x to the a plus b. Notice we kept the base, we added the exponents. To divide powers that have the same base, you keep the base and subtract the exponents. Notice it's the exponent in the numerator minus the exponent in the denominator, or the exponent in the numerator subtract the exponent in the denominator. To raise a power to a power, so see we have x to the a is a power, we're raising that whole power to another power of b. We keep the base x and we multiply the exponents. Be sure you notice the difference between the first one and the third one. In the first one, you are multiplying two powers that have the same base. In the third one, you're raising a single power to a power. So to raise a power to a power, you keep the base, you multiply the exponents. If I have a product, x times y, raised to the 8th power, the exponent a applies to both factors. So the a is applied to the x, the a is applied to the y. And the same thing is true for division. If I have x divided by y raised to the a power, in other words, a quotient raised to a power, the exponent applies to both the dividend x and the divisor y. We will be using these properties as we raise powers to powers. Let's start with an example of multiplication that you really already know how to do, but just get us back up to speed. So look at 2.3 times 10 to the negative 3 times 4.5 times 10 to the 6th. Now notice everything is multiplication. 2.3 times 10 to the negative 3, 4.5 times 10 to the 6th. I can regroup and reorder any way I want to. So I want to put the 2.3 and the 4.5 together, and I want to put the 10 to the negative 3 and the 10 to the 6 together. So I can regroup and do that by the associative and the commutative properties. Now any calculator will do 2.3 times 4.5. So you don't need a fancy calculator to do those. Anyone will do it. So I can do 2.3 times 4.5, and we get 10.35. So we have 10.35, and I'll multiply the number part together. Now to multiply powers having the same base, we keep the base and add the exponents. So it would be keep the base 10, add the exponents, negative 3 plus 6. Now that, of course, is equal to 10.35 times 10 cubed. Negative 3 plus 6 is 3. Now this is not scientific notation, so I need to put it in scientific notation. Remember, in scientific notation, the decimal needs to be, there needs to be only one digit to the left of the decimal. So what I need to do is divide this by 10 so I can move my decimal over 1. Now, of course, if I divide by 10, in order to keep everything equal, I've got to multiply by 10. So I get 1.035 times 10 to the 4th. Now 10.35 divided by 10, move my decimal one place to the left, is 1.035. Now to multiply powers having the same base, and it's understood to be 10 to the 1st, I keep the base 10 and add the exponents. 3 plus 1 is 4. In this tape, we'll always round to 2 significant digits, and that's the advantage of scientific notation. The left part, the digit part, always gives you the number of significant digits. So if I round off to 2 significant digits, it would be 1.0, because the 3 is less than 5, less than halfway. So this answer is approximately 1.0 times 10 to the 4th. Look at an example now of raising a power to a power. We have 2.3 times 10 to the negative 4 raised to the 5th power. Now we have a product in the parentheses. So the exponent outside the parentheses applies to each of the factors in the parentheses. So I can write it as 2.3 to the 5th times 10 to the negative 4 to the 5th. So the exponent 5 goes with 2.3. It also goes with the 10 to the 4th, 10 to the negative 4. Now I need to do 2.3 to the 5th on the calculator. So I do 2.3 to the 5th and hit enter, and notice we get 64.36343. Now to raise a power to a power, I keep the base and multiply the exponents. See, we're raising a power to a power, so I keep the base, multiply the exponents. Negative 4 times 5 is negative 20. So I do the decimal part on my calculator. 2.3 raised to the 5th power, and as you saw on the calculator, we got 64.36343. I can do the power of 10 part by using the rules of exponents. To raise a power to a power, I keep the base, multiply the exponents. Now again, I need to put this in scientific notation. So I need to have my decimal between the 6 and the 4. So it means I need to divide this one by 10. To keep everything equal, I need to multiply over here by 10. When I divide 64.36343 by 10, I get 6.436343. And now to multiply powers having the same base, I keep the base and add the exponents. Negative 20 plus 1 is negative 19. Rounding to 2 significant digits, I get 6.4 times 10 to the negative 19.